Have you ever wondered just how big the universe is? If so, you're in for a real treat, because we are about to take a journey through the vast expanse of the cosmos and explore the magnitude of its size. From the tiniest particles to the largest galaxies, this video will break down the universe's size comparison and explain how it all fits together. So get ready to have your brain broken by the sheer size of the universe. Hello, welcome to InWonder. Before I start, please subscribe to our channel for more amazing content every day. And don't forget to like and share this video. Let's get started. The vastness of the cosmos is impossible for our minds to fathom. In a word, it's massive. We can just guess, not comprehend the whole volume. It's not possible for any human brain that could ever hope to fathom the total scale of the universe, although it's hard for our minds to wrap around.
This place makes me wonder.
Do you know how scientists measure the cosmic distance? They use several methods. The use of the parallax phenomenon is one method. Everyone has access to first-hand parallax experiences. When you close one eye and hold your thumb up, it appears to be in a specific location related to whatever is behind your thumb. However, the illusion of motion is broken if you close one eye while keeping the other open. When we gaze at the stars, the same thing occurs. When viewed from Earth, nearby stars appear to be located at a specific angle with respect to the other stars in the sky. The same star will appear in a different position relative to the background, like opening and closing one eye. It happens the same 6 months later, when the Earth is on the opposite side of the Sun. We can figure out where the star really is by watching how it seems to move across the sky. The farthest visible parts of the universe are roughly 46 billion light-years away. To put that in perspective, the diameter of the Earth is 540 sextillion, or 54, followed by 22 zeros miles. But this is merely a hypothesis based on the best available data. The true size of the universe remains unknown. This is because our vision is limited to the distance light, or more precisely, the microwave radiation emitted by the Big Bang has traveled since the beginning of the universe. Expansion outward has been the norm for the universe ever since it exploded into being around 13.8 billion years ago. It is difficult to estimate how far the universe goes beyond the visible universe, because we do not know the exact and precisely accurate age of the universe. However, astronomers have looked to a feature called the Hubble Constant to aid them in this endeavor. Wendy Friedman, an astrophysicist at the University of Chicago who has spent her career measuring it, describes it as a measure of how fast the cosmos is expanding at the present time. It is the Hubble Constant that determines how old and how big the universe is. A helpful mental image is to imagine the expansion of the universe as a balloon. The greater the distance between stars and galaxies, like dots on a balloon surface, the faster they are moving apart from each other. This means that galaxies are receding from us at a faster rate as they get further away. The problem is that the more astronomers measure this quantity, the less it seems to conform to expectations based on our knowledge of the universe. There is a discrepancy between the results of direct measurements and indirect measurements that rely on our knowledge of other properties of the universe. Either our understanding of how the universe functions is erroneous, or the measurements themselves are flawed. Now though, scientists who are trying to figure out the Hubble constant think they are getting closer to the truth by doing tests and making observations. The Hubble constant is named after the astronomer Edwin Hubble, who made the first accurate measurement of it in 1929. He found that light travels at a rate of around 500 kilometers per second per megaparsec, chem per second, MPC, or about 310 miles per megaparsec. This statistic indicates that galaxies are receding from us at a rate of about 500 kilometers per second, 310 miles per second for every megaparsec, a unit of distance equal to 3.26 million light-years, further from Earth than the observer is. Since Hubble's first estimate of how fast the universe was growing more than a century ago, that number has been changed many times to be smaller. Current calculations place it between 42 and 46 miles per light-year, 67 and 74 kilometers per second, MPC. The Hubble constant can be measured in multiple ways, which is a contributing factor to the issue. One method uses how fast galaxies close to us are moving away from us, and the other uses the cosmic microwave background, CMB, which is the first light to leave the Big Bang. This light is still visible to us today, though it has been stretched into radio waves as it travels through the expanding universe. These radio waves, which were accidentally found in the 1960s, provide us with the oldest possible glimpse of the early universe. Gravity's pull and radiation's outward push caused a cosmic tug-of-war in the early universe. This caused disturbances that can still be seen as tiny changes in the temperature of the cosmic microwave background. These changes can be used to figure out how fast the universe grew in the past. Then, the standard model of cosmology can be used to figure out how fast it is growing now. The standard model is one of the best theories for the origins, composition, and current state of the universe. With our simple thoughts, let us see how big our universe is. Just think that nearly 3 days are required for a trip to the Moon, 7 months to Mars, 15 months to Venus, 6 years to Jupiter, 7 years to Saturn, 8.5 years to Uranus, 9.5 years to Pluto, and 12 years to Neptune. The distance to the Sun is only 0.00001581 light-years. Thus, we may be there in 25 days. When all is said and done, how vast is the cosmos? Roughly, it is 93 billion light-years away. All right, let's revisit the Sun once more. The distance to the Sun in astronomical units, AUs, is 1. We could make the trip in 25 days if we were in peak physical condition. A single astronomical unit equals 149,598,000 kilometers, or 92,955,887 miles. A light year is equal to 63,000 astronomical units, and there are 93 billion of them in our vast universe. That means the diameter of our universe is 93 billion light-years, or roughly 9 trillion kilometers, 6 trillion miles. As vast as our universe is, we haven't even scratched the surface. The 93 billion years only refer to the part of the universe that is visible to us right now. It's possible that the entire cosmos is at least 7 trillion light-years across, or 250 times larger than the observable universe. Its full size may be much more terrifying, according to some scientists. Scientists have calculated that the universe is at least 7 trillion light-years in diameter, or 250 times larger than the observable universe, using the Bayesian model average. As opposed to questioning how well a model fits the data, the Bayesian model is concerned with the probability that a given model is right. The accuracy of this estimate of the universe's size is, however, questionable. There are still many reasons to believe that the size of our universe is bigger than the size of the universe we can see. What happens when the universe collapses? Many cosmologists think the universe will continue to expand forever. Some have speculated that it will collapse on itself one day. The most obvious explanation is that with the death of the stars, the universe will cease to exist since there will be no more light to illuminate it. If there are other ways to survive, the universe won't come to an end. As the universe continues to expand, some predict that it will gradually cool, eventually killing off all life within it. The Big Freeze is the name of the theory in question. There is also the theory that the expansion of the universe will eventually stop and even reverse. This would cause the universe to collapse once more, possibly ushering in a new Big Bang as a result. The Big Crunch is the name for this potential outcome. The Big Rip is the name of a third widely held belief. According to this idea, even the smallest building blocks of matter, the atoms, will be shattered to pieces. If the hypothetical energy, known as dark energy, ever overcomes gravity, this is what will happen. Regardless of the specifics, we may rest assured that these end-of-the-world scenarios are still billions of years away. So we can say that the universe is an incredibly vast and mysterious place, and it can be difficult to comprehend just how big it really is. We've talked about how big it is, how old it is, and the different theories that try to explain how big it is. Have you thought about how small we are compared to this universe? Despite that, we run after this universe, hoping that one day we can figure out all its secrets. Thanks for joining us on this journey through the cosmos. Until next time, keep looking up.